Okay. I am sorry I am not here again today. I don't know what's happening with my family, but my son is sick again. And so it's Sunday right now while I'm making this video. And he's already thrown up 7 times. So I'm not certain what's going on, but anyway, I will not be here today on Monday. So first thing I need you guys to do is get your linear equations part 1 packet out and turn this in. Please make sure you have your name on it, first and last, and if you could put the period that you're in, that would be awesome. So everyone, get this out of your backpacks and get your name on it, first and last, put your period number on there, and turn those in. Okay, hopefully everybody has had enough time to turn that in. And now we are going to go over linear equations part 2. And if I'm going too fast, if you don't have the papers turned in, then you can always pause me until everybody's caught up. Okay, today we are going to review writing equations of lines. So this is also an Algebra 1 topic. But sometimes students don't do as well with this one as they do with the linear equations part 1 material that we went over with the other day. So we have 3 different forms for writing an equation of a line. Point slope form, this one is very popular, and we use point slope form whenever we see points, and if we have a slope, then it's ready to go. So point slope form is when you have a point as well as a slope, but if you only have points, then we can use point slope form. We'll just have to figure out the slope first. Then typically, once we get an equation in point slope form, then we convert it into slope intercept form. And of course, everyone's very familiar with slope intercept form. And this is the form that we use anytime we're given a slope and a y-intercept. And then this one in the middle is called standard form. We don't use this one very often, but this is what standard form looks like. It's where the x and the y are both on the left-hand side of the equals, and the constant, the number without the variables, on the right-hand side of the equals. When equations are in this form, there is a way of graphing them very easily, and that's by plotting x and y intercepts. So that's when standard form is really nice, is if you're graphing x and y intercepts. Okay, first thing we're going to practice is point slope form. And this should look very familiar to everybody. So it goes y minus y1 equals m times x minus x1. This is where the y-coordinate of the point goes. This is where the x-coordinate of the point goes. And the m is where the slope goes. This y and this x right here, those always just stay right where they are. Okay, after we put our equation in point slope form, we are going to change everything into slope intercept form. So our final answer is going to be in slope intercept form. So let's just try some. All right, remember I told you if you ever see a point and a slope, then we're going to use point slope form, just like the title suggests. So whenever I have a point and a slope, it's going to go straight into point slope form. This is the x-coordinate, so it will go into the x1. This is the y-coordinate, so it will go into the y1. And this is the slope, so it will go into the m. And let me go ahead and just write down point slope form. And then I'm just going to start plugging everything in. I find the more I write the equation, the more I have it memorized, the more I know it. Okay, so here I go. I'm going to go y minus, which one's the y coordinate? -4. And I can go ahead and change this minus a negative into a plus. Equals, what's the slope? -1. And then parentheses x minus, which one's the x coordinate? 0. Okay, here it is in point slope form. But I'm going to go ahead and I'm going to convert it into slope intercept form. So the way I do that is first I distribute the -1. -1 times x is -1x. And -1 times 0 is 0. And I could put the 0 or not. I'll go ahead and I'll put it this time. And then I just bring down my y plus 4. My goal is to get y by itself. So to get y by itself, I have to move this positive 4. And I'm going to do that by subtracting 4 from both sides. 4 minus 4 is 0. Shoop, that's gone. I drop the y. I drop the equals. I drop the -1x. And then what is 0 minus 4? -4. And of course, the other way I could write this is not write a -1 in front, just write y equals -x minus 4. Either way, they both mean the same thing. This is the one that you most often see. And there it is. So hopefully this seems very familiar to you, and hopefully you don't find it to be difficult. All right, let's go ahead and try number 2. Once again, I'm going to go ahead and just write down my point slope formula. Y minus y1 equals m times x minus x1. And then I'm going to just start plugging things in. So it always goes y minus, which one's the y coordinate? -6. So the minus the negative is going to turn into a plus. And then equals, which one's the slope? -8. And then in parentheses, it always goes x minus. Which one's the x coordinate? 3. So I put the 3. So it always goes y minus x minus. It's just if you subtract a negative, that will turn into a plus. Okay, next thing I do is I distribute. So -8 times x makes a -8x. -8 times -3 makes a positive 24. And then I'm just going to drop my y plus 6. And then my goal is to get y by itself. So how do I get rid of that plus 6? I subtract it. So I'm going to subtract 6 from both sides. And everything starts dropping like flies. The y drops. The equals drops. The -8x drops. And then what is 24 minus 6? 18. And there it is. There's my equation in slope-intercept form. Okay, I want everyone to take a moment and try number 3. So I'm going to give you 30 seconds to a minute to do that, and then we'll go over it and see how you did. So everybody try number 3. Does everybody have it? Or am I rushing you? Hopefully everybody has it. And number 3 should have turned out looking something like this. So take a second and see if it does. So both of these stayed y minus, x minus. The reason they didn't turn into a plus is because I never subtracted a negative number. So it's always y minus, x minus, unless you have to subtract a negative number, and then that's when it turns into the plus. Okay, so we are going to move on to the next page. Okay, down here, I'm still trying to write an equation for the line. So you notice how on this page all you see are points, 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 points. So anytime I see points and I want to write an equation of a line, I know I'm going to put the equation in point slope form. So let's see, what are we missing from our name? We have points. Yep. Do we have slope? No. So that's the first thing we're going to have to find. And my box up here, it tells you exactly what to do. So the first thing I have to do is I have to find slope using my slope formula. And then once I have that, we can continue on. So let's look at number 1. So first thing I need to do is find my slope. So I'm going to take y2 minus y1. So 1 minus 5 over x2 minus x1. So negative 4 minus a negative 2. Of course, that minus the negative turns into a plus. 1 minus 5 makes negative 4. Negative 4 plus 2 makes negative 2. And if I divide, I get a positive 2. Okay, once I have my slope, then I pick the point I want to use. So I either can pick this first point or I can pick the second point, whichever one I feel like I would rather use. So it really doesn't matter. Sometimes I'll pick the point that has the smaller numbers, and sometimes, I'll just pick whatever, is the first point. It really doesn't matter. So once I have my point that I've selected and my slope, I have everything I need. I have my point, I have my slope. So right now, I'm ready for point slope form. Let me go ahead and write it down again. And I'm going to start plugging in everything that I know. So y minus, okay, of this point I selected, what's the y coordinate? 1 equals, what do we find the slope to be? 2. And then in parentheses, x minus. So of the point I chose, what's my x coordinate? Negative 4. And of course that minus that negative right there will make a plus. Okay, so this is point slope form, but remember I said that we're going to convert everything into slope intercept form before we're done. So here I go. I need to distribute the 2. So 2 times x makes 2x. 2 times 4 makes 8. And then I just drop the equals and I drop the y minus 1. Okay, at this point I need to get y by itself, so I need to move the minus 1. So I get rid of a minus 1 by adding 1. And then everything starts dropping. The y drops, the equals drops, the 2x drops. And how much is 8 plus 1? 9. And there's my answer. Now I wanted to show you something real quick. I wanted to show you that even if I had picked the other point, so let me slide this over, and you can see both at the same time. Even if I had selected the other point, you still get the same answer no matter which way you do it. So you can pick either point you want to use, it doesn't matter. In this one I chose the second point and I got an answer, y equals 2x plus 9. In this problem I selected the first point and I got the same answer. So it doesn't matter which point you pick whichever one looks the easiest to you, or just go with your gut and just pick one. But it doesn't matter which point you pick. Okay, I want to try one that has some fractions in it. So let's hop all the way down to number 6. Okay, so remember, anytime I see points, I know I'm going to put it in point slope form. So what am I missing from my name? Slope. So that's the first thing I have to find. So y2 minus y1, 5 minus negative 1, which turns into 5 plus 1, over x2 minus x1, 6 minus negative 8, which is the same thing as 6 plus 8. 5 plus 1 makes 6. 6 plus 8 makes 14. I can divide both of those by 2, and if I divide both of those by 2, I get 3 over 7. So once I have my slope, I'm going to pick my point. Doesn't matter what point you pick. I'm going to go ahead and I'm going to pick this first point. But some of you might have picked the second point just because they're all positive numbers. It's up to you. Okay, so I'm going to go ahead and write down my point slope formula. And I'm going to start plugging everything in. So I go y minus the y-coordinate, which is the y-coordinate of my point, -1. So that's going to turn into a plus, equals slope, and we found the slope to be 3/7. In parentheses, it always goes x minus, okay, the x-coordinate. Which one's the x-coordinate? -8, and that minus the negative turns into a plus. Okay, at this point, I need to distribute if I want to get it into slope-intercept. So 3/7 times x, that's 3/7 x. Now I need to take 3/7 times 8. So instead of doing a mini lesson on how to multiply fractions by hand, I'm going to show you with the calculator. So every time I put fractions in the calculator, I'll use a parenthesis, and then I go 3, then I hit the divide button. So 3 divided by 7, I close my parentheses, and I'm taking that times 8. And if I want this back into a fraction, which I do, I'm going to hit this side button here that I talked about the other day, math, enter, enter. And so 24/7 is the fraction you get. And when I see you next, if you want to know how to do that by hand, I would be happy to show you if you don't remember. The y plus 1 is just going to drop down. And then to get y by itself, how do I move this plus 1? I subtract 1. So I'm going to subtract 1 from both sides. The y will drop. The equals will drop. The 3/7 x will drop. Now I just need to figure out what 24/7 minus 1 is. And some of you in here that are good at fractions probably already know. But this is what I'm going to do. I'm going to go parenthesis, 24 divided by 7, close the parenthesis, minus 1. And then I'm going to go math, enter, enter. And it gives me my fraction of 17/7. And it's positive, so I go plus 17/7. And there it is in slope-intercept form. Okay, let's move on to the next page. On this page, we're talking about parallel and perpendicular lines. So parallel lines, they look like this. They have the same amount of incline, so that means they have the same slope as one another. They do have different y-intercepts. That way they are in different positions on a graph, but they have the same slope, so they have the same incline. Okay, now perpendicular lines, on the other hand, their slopes are called negative reciprocals, or you might have been told opposite reciprocals. So parallel lines have the same slope as one another because they have the same amount of incline. That way they don't run into each other. And perpendicular lines, these are lines that intersect, and when they intersect, they form 90-degree angles. And so in order to be perpendicular, their slopes have to be what are called negative reciprocals or opposite reciprocals. So I want to practice what opposite reciprocals are for just 1 second. So if I give you the fraction -3/4, what is the opposite reciprocal? 4/3. You flip the fraction and switch the sign. So if the fraction was negative, it becomes positive. If the fraction would have been positive, then when you flip it and switch it, then it would become negative. So opposite reciprocals are flip and switches of each other. Flip the fraction, switch the sign. It goes from negative to positive, or it goes from positive to negative. These are opposite reciprocals. These are opposite reciprocals. So if I gave you a fraction of 2/5, what would the opposite reciprocal be? -5/2. Okay, what if I gave you -3? What's the opposite reciprocal? 1/3. Because this -3 is understood to be over a 1. So if you flip the fraction and switch the sign, you get a positive 1/3. So last year in Algebra 1, I made up a song about parallel lines and perpendicular lines. So some of you out there may know it. And if you don't, maybe I'll sing it to you next time I see you. Okay, let's just look at some of these. So number 1 here, I'm trying to write an equation of a line. I want it to go through this point, and I want it to be parallel to this line. So first thing I'm going to figure out is what's the slope of this line right here. This line right here has a slope of -2. Remember how the slope's the number smushed against the x? So if I want a line parallel, this says the slope of the parallel line is, what would the slope of the parallel line have to be? -2 as well. In order for lines to be parallel, they have to have the same slope as one another. So if this line has a slope of -2, my parallel line has to have a slope of -2. So once I know my slope is -2, and I know it's going to go through this point, I have everything I need for point slope form. Because I've got my point, I've got my slope. So point slope form, remember, goes y minus y1 equals m times x minus x1. So here I go. I go y minus, which one's the y coordinate? 1 equals, I want the parallel slope. Would we say the parallel slope is? -2. And then x minus, which one's the x coordinate? -4. And then, of course, that's going to turn into a plus. And then I just have to convert it to slope-intercept form. So here I go. I'm going to distribute. -2 times x makes -2x. -2 times 4 makes -8. I drop the equals. I drop the y minus 1. And then how do I get y by itself? I move the -1 by adding 1 to both sides. And everything starts dropping like flies. The y drops. The equals drops. The -2x drops. And how much is -8 plus 1? -7. And this is the equation of my line that would be parallel to this one that they originally gave me. See how these two lines have the exact same slope, but different y-intercepts? So I know that these two lines would be parallel. They would both go downhill, something like this. Okay, let's cruise down to number 3. On number 3, I want my line to go through the point -6, -1. This time I want it to be perpendicular to this line. So first thing I ask myself is, what is the slope of this line right here? This line right here has a slope of -2, because that's what's smushed up against the variable. I want the slope of the perpendicular line. So I'm going to use an upside down T. The slope of the perpendicular line is, remember, opposite reciprocal, flip the fraction, switch the sign. What would you get if you flipped this fraction and switched the sign? 1/2, because remember, this is understood to be over a 1. So if you flip the fraction and switch the sign, you get a positive 1/2. Okay, so this is the slope I want, and this is the point I want to take it through. So I've got my point, I've got my slope. So let's just go. I'm not going to write the equation this time. It goes y minus the y coordinate. Which one's the y coordinate? -1, that turns into a plus, equals my perpendicular slope, and my perpendicular slope is 1/2. And then in parentheses, x minus, what's the x coordinate? -6, that turns into a plus. Okay, time to clean it up. So I'm going to distribute 1/2 times x, that's 1/2 x. Now 1/2 times 6, you could use your calculator if you need to, but what's half of 6? 3. And it's positive, so I go plus 3. And then I bring down the y plus 1. And my final step, I just need to get rid of the plus 1, so how do I do that? I subtract 1 from both sides. The y drops, the equals drops, the 1/2 x drops, and how much is 3 minus 1? 2. And there's my answer. So parallel lines have the same slope as one another, and perpendicular lines, their slopes are opposite reciprocals. let's go. I'm going to jump around a little bit here. I'm flipping the page, and I'm going to go to this one that says More Examples. And then I'm going to backtrack back up here. It says, find the slope-intercept form of an equation of the line perpendicular to the graph of x minus 3y equals 5 and passing through 0, 6. Okay, so I want it to go through the point 0, 6, and I want it to be perpendicular to this line. So I'm going to start off like I did those last couple problems. I need to know the slope of this line. Do you notice anything different about this problem? This problem is not in slope-intercept form. I don't know the slope right now. The equation needs to be in slope-intercept form, so that way the slope will be the number smushed against the x. And since it's not in slope-intercept form, I have to fix it. I have to make it like that. So I'm going to circle everything smushed with my y. Whatever's outside the circle, I'm going to add or subtract to make it go away. So since that's a positive x, I'm going to subtract x from both sides. X minus x is 0. Shoop. In my circle, I have a minus 3y, so that's going to drop down. On the right-hand side, I recopy the minus x, and then I recopy the positive 5. And then the last step, you divide by whatever's in front of y. So I'm going to divide both sides by negative 3. And then I just clean it up. This makes y equals, what's in front of this x right here that you guys don't see? A negative 1. So what does a negative 1 over a negative 3 reduce to be? A positive 1/3 x. And then can you reduce 5 over negative 3? No, but what's a positive over a negative? A negative, so that's a minus 5/3. Okay, now that I have it in slope-intercept form, what's the slope? This line right here has a slope of 1/3. Okay, I want the perpendicular slope, so what would the slope of the perpendicular line be? Negative 3. Flip the fraction, switch the sign. Okay, so here's the perpendicular slope I want. Here's the point I want to take it through. So since I have my point and I have my slope, I'm ready to go. So it goes y minus the y-coordinate. Which one's the y-coordinate? 6 equals the perpendicular slope, and we found that to be negative 3. In parentheses, x minus the x-coordinate. What's the x-coordinate? 0. Okay, there's point slope form. Now let's distribute and clean them up. Negative 3 times x makes negative 3x. How about negative 3 times 0? 0. Okay, I could write it or not. I'll go ahead and write it. Then I'm going to drop the y minus 6. Now how do I get y by itself? Add 6 to both sides. So I get rid of the minus 6 by adding 6 to both sides. And things start dropping like flies. Drop the y, drop the equals, drop the negative 3x. And what is 0 plus 6? 6. And there we go. There's our equation. That's perpendicular to this original one. And it goes through that point. So the reason this was a little more complicated was because the initial equation was not in slope-intercept form. And so I had to put it in slope-intercept form to begin with. And then once I did that, I could tell that the slope was the number in front of the x. I flipped it over, switched its sign, and then I got my perpendicular slope. If I backtrack up to these examples, where it says find the slope, what would I need to do to all of these problems if I want to find the slope? I would need to put them in slope-intercept form. Once they're in slope-intercept form, then the slope's going to be that number in front of the x. So I'm going to do number 3 real quick. I'm going to circle everything smushed with my y. Whatever's outside the circle, I'll add or subtract. So to make a positive 6x go away, I'm going to subtract it. And then 6x minus 6x is 0. Shoop, that's gone. Going to drop the negative y. I'm going to drop the equals. This side I recopy, so I recopy the minus 6x. And I recopy the positive 8. Now what's in front of y that I'm going to divide by? A negative 1. So I'm going to divide both sides by -1. And then what's a -6 divided by a -1? A +6. So a +6x. And what's 8 divided by -1? A -8. Okay, now that the equation's in slope-intercept form, what's the slope of this line? The slope is 6, because that's the number that's smushed up against the x. So that's how I have to do that section there. Okay. I want to go back to the very front page, and I want to talk about the problems I want you guys to do for me for homework. Okay, so the very first one that I want you to do, and I'm back on the very front page. So on the very front page, I want you to do number 4 for me. So number 4 I want you to do for homework. Okay, let's turn the page. On the second page, where you see all the points, I want you to do number 4 and number 5. Okay, let's flip the page. On this page where we were talking about parallel and perpendicular, I want you to do number 2. And I want you to do number 4. Okay, let's flip the page. On this page, I want you to do number 7. And I want you to do, in this section where we were finding the slope, why don't you go ahead and do the number 2 there. And then on the bottom of this page, I want you to do this number 2. Okay, let's flip the page. On this page, I want you to do number 3 and number 4. These problems are very easy. All they want to know is what would the slope of a line parallel be, and what would the line, a perpendicular line, have a slope of. So those are very easy questions. And then this stuff is review from the other day, trying to write the equation of the following lines. So I'm going to go ahead and ask you to do 1, 2, and 3. This is just review from the first packet that I taught you. And then the bottom section is graphing. So what do you notice about these problems? None of them are in slope-intercept form. You would need to put all of these equations in slope-intercept form first, and then you'll know what the slope is, and then you'll know what the y-intercept is, and then you can graph it. So of this section here, I want you to do number 1 and number 2. And that's it. So I don't know how much time you have left right now, but hopefully you have a little bit of time you can work on it, and if you don't, I'm sorry. This will be homework, and I will be looking for this on Tuesday. So hopefully it doesn't take you a great deal of time. Thank you so much, and I'm sorry I'm not here. I'm sorry my son's sick, and hopefully I see you tomorrow. Oh, one more thing. Smiley face.